So today I will be telling you a brief description about my arrhythmia detection code using ECG signal. So this is the code for that. Now first of all, I have imported all the libraries, that is pandas, numpy. The most important library that is used in this project is biospire library because it helps us to find the RPs, which is very much required to detect if your heartbeat is normal or like affected. And then we have this warning filters library to ignore the warnings. Now comes the part of data augmentation. Now one of the things about our project is that the data was highly imbalanced. As I mentioned in the comment section, that the data was highly imbalanced, which means for every 1,000 rows of normal heartbeat, we had just one or two not non-normal heartbeats, that is ventricular affected or auricle affected. So that's why I have to do data augmentation. And the best thing about data augmentation is that it is most effective on images, and we had only 1D or audio data. So in this program, using a technique, I've been able to convert my 1D signal to a 2D signal, and then I've used this data augmentation to increase my data set for the non-normal heartbeats. So here comes the cropping method. So I've used left top cropping. There are several methods. I've used left top crop, center top crop, and in this way there are many techniques to do cropping. So this is the part of data augmentation which was highly required to make my dataset balanced so that there is no biasness at the time of the output. Now come to the main code. So inside the non-normal heartbeats, it is further divided into L, A, and V. So, but in this case, due to like the RAM was not that much sufficient, so I've been able to do only normal and non-normal heartbeats for right now. So in this way, like I've used a function called biospy signals ECG Christoph segmenter. It will help me to find the number of our peaks. Now the problem with this function is that it has a certain condition. Like it will work only if your data has at least, let's say, 5 non-normal rows in your data set. So if I now these are all the files that was required to find the minimum number of non-normal heartbeats. If I used only one file, I think that for each 2,000 rows I had only one non-normal heartbeat, and therefore this function was not working at that time. So I had to import 20 files, and then there was sufficient number of rows that had, let's say, 10 non-normal rows, and then only this function was able to work. Now I've concatenated everything into a single big R file, CSV file named R. Then I've used standard scaler because the values were very large and it would have taken much time to process on the larger values. So I've used data normalization technique, which is standard scaler. And then like for each either normal or non-normal, we have to find the number of RPs, and then using a technique convert those 1D audio signal to a 2D image signal so that those 2D image can be data augmented as I've shown you in the above part. So in this part of the program, I've been able to find number of R peaks for the normal and the non-normal data, and then I've appended in a list. Then using this technique, this method technique, I've been able to convert those 1D R peaks to 2D R peaks. That is, convert the 1D audio signal to a 2D image signal. Again, I'm saying that the image, my main aim to convert 1D to 2D was to balance the number of normal and non-normal beats to avoid imbalancy or biasness. Then I've used plt.histogram to plot my image R peaks in the form of an image. Then I've stored those files, converted them to grayscale because processing on grayscale is always more efficient and easy. Then I've resized the image so that when I will train the model, it will take less time to train. Then I'm cropping that. This is the part of data augmentation. It will call the above function, and as you can see that these are the number of peaks for the normal heartbeat signal. And then you can see that these are the labeling part, because you have to label which beat is normal and which is not normal. So here I have mentioned non-normal as L, A and V, but in the future program it is as normal or non-normal. Then I have to do modeling or training. So I have used VGG Net Model for this part because it was most efficient on this data set, VGG Net Model. So since it is a pre-trained model, so the architecture was already there. I just tuned the hyperparameters for this. Like I converted it to 64 cross 64. Otherwise, it was taking much time to train. And then in this step I'm making the convolution 2D layer to extract the features from the image. Then I'm doing batch normalization to downscale my data. Then I'm doing max pooling to like reduce the dimensionality of the image. Then I'm again doing, like, it is a pre-trained architecture, and the method is repeating at regular intervals. So after my model is completely made, and this is the last output layer to tell if it is normal or not normal, and I've used activation as softmax. Then I'll compile, and then we have used Adam optimizer because it was the most efficient one, and accuracy as the matrix. So from this method, I've imported my images from my local computer personal file, and then I've used fit generator. And as you can see, after doing 4 epochs on 64 cross 64 images, I've been able to get an accuracy of 80% at last. It's 30, 60. Average is around, let's say, 55 or 60, and at last I've been able to get around 80% accuracy. So thank you.